So hello everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be exploring how to automate day two networking with HashiCorp Consul. My name is Connor Beechinor. I'll be your moderator for this session, and today I'm delighted to welcome both Jason Broadbent and Yona Applebaum, who are senior solution engineers here at HashiCorp and will be your speakers today. So just to run through some general housekeeping before our speakers kick things off, we will have a live Q&A session at the end of today's webinar. So if you do have any questions, please post them in the Q&A box at the bottom of your Zoom window. And as I say, we'll answer those at the end. Also, just to let you know that this webinar is being recorded and we'll send that out to everyone via email after it's been processed. That usually takes about 24 hours. All right, so with that, let's get started. Over to you, Jason.
Hey, thanks, Connor. Hey, good morning, everybody. Hope everyone's well. Today, myself, Jason Broadbent, and Yona, we will go through a demo of automating some firewalls and some load balancers, and then we'll talk through how it all works. So that's the plan this morning. So sit back and enjoy. Any questions, please feel free at the end, and we'll get to them.
Hi, everyone. I'm Jonah, by the way.
Hey, Jonah. So without further ado, we'll start our demo. So currently, where we're at, we're within a environment which is safe for us to play. We've created a console and data center environment. We have our applications and we have our code available. Jonah.
Yeah. Hey, Jace, quick question. I've just deployed a set of new VMs, a set of new instances of my service. Could you do me a favor? I just opened a ticket for that. Could you just enable the firewalls and a load balancer for these instances?
Yeah, sure. So I'll create some IP addresses now from instances on our firewall for you. That'd be absolutely perfect. So let me go through our virtual server list and I'll add a server. Right.
Well, wait a minute. Are you going to do that for every single instance?
Yeah, I'm going to do that for every. Is that a problem? Is that okay?
Oh, yeah. I want to show you a better way of doing things. As you know, I've been dealing with some of these automations for a company. I just want to show you something new that we have. So it's called Consul Terraform Sync. Have you heard about it?
No. Will this save me time instead of setting up all these addresses?
Oh, it will not only save you time, it will save me time as a developer. It will save us time as a company. So
you're not going to solve any more tickets for me then for just setting up IP addresses?
Oh, yeah, you're still going to have
cool.
tickets.
Thanks, man.
We're going to make the whole process just way easier for you, right? So let me quickly introduce you to Terraform Sync here. Basically, what you were about to do is my services in Consul. You were going to add an IP address per service, or maybe a subnet if you do a loose grain policy. But what Terraform Sync will do, it will synchronize all healthy instances, very important word healthy here, and automatically update my F5 and my Palo Alto, right here, my big IP and my firewall. So instead of you doing the manual work of what you were just going to do, Consul Terraform Sync here in the middle will talk to Consul, will ask about its healthy instances, it will dynamically update these things. So what do you think?
I like it. I like it. So can I just show? Can I just go back into my big IP tab and just see what pools I have available, so we can see before and after? Okay. So I have no pools currently. That's cool.
You have no pools. So what I'm going to do is and by no means I'm taking away your roles and responsibility here. The way this works is Consul Terraform Sync is a set of Terraform modules that will be used to talk to your appliances here. So let me show this to you quickly, very quickly behind the scenes. What this will do, this will use a Terraform provider. It will call a set of modules to update these firewalls. So these modules can be totally managed by you or by your team, right? And we as a developer team will just provide the Terraform the right values for it to update your firewalls and load balancers, right? So what I'm gonna do here as a first step, I'm gonna deploy my Terraform Sync, which is basically a virtual machine with a console client and with a Terraform agent that will just do the work for me, right? Or for us. So I'm gonna here. So this is right now what I'm doing is, again, it's a typical Terraform plan. So I'm deploying a VM. I agree with what's going to happen. This is a typical Terraform workflow. I approve it. And I'm now going to apply that new setup. So basically what this is doing behind the scenes, this will deploy this little VM here. It will deploy a console agent because we need that agent to talk to console, right? And we also deploy that little Terraform Sync tool that we just talked about. They will dynamically update your firewalls and load balancers. So what do you think so far? Is that something you would accept?
I like that. Can you see that within console being built? Can we see it?
Yeah, absolutely. Absolutely.
As it's going through.
Yeah. So we're gonna see an extra. We're just gonna see here an extra node appearing, right? Which is gonna be the Terraform Sync node that is gonna be registered, and it's gonna have a Terraform Sync service assigned that's gonna do the work. So we're gonna see that appearing as soon as it has done the work. So let's see here. It should be here. Oh, I need to refresh. Thank you very much.
May take a little time.
Yeah.
And then I'll start seeing those IP addresses for those services for the web and application come up in my pull address, right?
Yeah, it's that. So now, right now, yeah, this is exactly. This is going to happen. Takes a bit of a time, right?
Yeah.
Takes a bit of time because right now Terraform has started and it needs to start doing its job, right?
That's right.
Yeah. So basically, right now in the backend console, the Terraform Sync is talking to console and updating the firewalls and everything in the backend, right?
Yeah, that's cool. There we go. It's starting to come up. I can see it. There you go. So take it. So I'll refresh that. But so I just saw the VM come up then within console. That was cool.
Oh yeah, sorry. Yeah, here it is. You see it's coming up. So that means that the service is coming up. It's starting up the service, and in a little while we'll see my my big IP updated, and like magic, you'll see that your firewall is going to be updated. Yeah,
so console has a great bird's eye view of everything, right?
Yeah, absolutely. So CTS is here, right? My nodes are up and running. So if I go to my big IP now, I should see the pool list updated. Oh, it's going to take a while.
Should I have a quick look?
Yeah, sure. Like carry on for yourself. Yeah.
Yeah, let me have a quick look. It's not that I don't believe these guys, you know, but there you go. So console Terraform Sync pool. Oh wow, look, I've got a web pool list.
Yeah.
And then I can see what IP addresses. Wow, that's cool. That saved me a bunch of time. Thanks, Yona.
That's absolutely well. But maybe check your firewall, your load balancer as well.
So my firewall rule. So my firewall rule is allocated to a service name rather than IP address, which means that so as that service adds more IP addresses, we can have that fine-grained rule manage all of that service and the amount of instances that are behind it. That's really awesome. Thanks, Yona.
Yeah, awesome. Cool.
Now, does my app now work? So let's have a look. Does my app now work? Because I couldn't access it before. Oh wow! So now my web can talk to my backend app, and I can see my hello world. Great stuff. So CTS is console magic, right?
Yeah. And also what's happening next, Jace? We have an event tomorrow. I'll need to update these instances up and down while the event goes. Well, we have an automatic event that will do that in the back end, right?
Okay.
So we will be scaling up and down all the time while the workload is increasing. So I just want to show you how that is going to happen. Are you okay? You want to see that?
Yeah, go for it. Yeah. It's saving me time. I've got a really busy day tomorrow.
Yeah, so I won't be bothering you with tickets then.
Oh, that'd be cool. Yeah, I've got to add some more servers and switches tomorrow, so that would be cool. So so what you're saying to me is, instead of going through a ticket process and me escalating tickets based on severity, this can be done in the back end automatically.
Yeah, absolutely. Yeah.
Nice.
So basically what we're gonna do here is I'm gonna run this command here, right? What I'm gonna do is I'm gonna increase the instances of my web server, right?
Yeah.
And I should see these IPs automatically updated in my big IP, right?
Okay.
And so you should be seeing these instances come up. Okay, are you okay with that? You want to see what's happening?
Yeah, let's go for it. That's great. That's going to save me a heap of time. So as these increase, you have visibility within console as it goes through its scaling and health checks for that particular VM, right?
Yeah. So basically, if one VM is overloaded, if one instance is overloaded, and it shouldn't be route any traffic, or there's anything wrong with that VM, Consul Terraform Sync or infrastructure automation is automatically going to update your load balancers and firewalls to just dynamically reflect that change.
Perfect.
So cool. It's going to modify it. So
you can use this to scale up for our busy day tomorrow, and then scale back down when we're finished.
Exactly.
Right?
So let's see if no, it's still not there. We'll wait for a few more seconds.
Still building.
There you go. So we should be seeing a new instance coming up very soon.
Yeah, take a little time. Go through its health checks within console first.
Yep.
You want to check it?
Oh yeah, I will check console first. Thank you very much.
So it's still building the instances out.
Yeah, let's wait. Still registering. There you go. There's a third instance coming up. As soon as that health check is going to be healthy, we should be seeing our big IP update.
Right, that's right. This is super cool. This is going to save us a heap of time, and this is just for one moment in time. This is not for all the other developers and all the other instances that we need as well through all the other busy times.
Right. Right, and this is just one service. What if you have many services? This just saves you a bunch of time here.
So it's much quicker than me manually entering all that information. I will know which instances are healthy as it's being built out within the public cloud providers, and as it becomes healthy, like one just did. Yeah, so app is now healthy. The web is now coming up. So we just need to reflect that within console, and eventually we'll get the. Here we go.
Here you go. How cool is that, eh?
I'm impressed.
This is awesome. This is also right. This is because I remember in the past, Jace, every single change, or till today, every single change just takes so much time, right? And so basically, like it just updated by the end of the day tomorrow, or auto scale or automatic scalers are going to automatically scale this down, right? So we're going to just simulate that for a second, and I'm going to make sure that my app and web count are just going to go back to 1, right? Well, essentially we usually have 2, but just to show what's happening in the back end, let's do that. Are you okay?
That's great. I mean, the finance team are going to be really happy with you, knowing how to scale up and scale down very quickly, save costs.
Yeah, so this is going to happen in the back end, and you're going to see, we don't have to wait. I mean, but you get the idea, right?
Yeah.
You get the idea of what's happening.
That's cool, man. Yeah, thank you for that insight into a bit of DevOps automation. That's cool. Right, sure.
Let's just wait till this is a lot.
See we go down to 1. Yeah.
Yeah, we should see go down to 1 in a second. As you know, before it just takes a time to console Terraform Sync to go through its health checks and everything else. But within a couple of minutes, we should be seeing both the.
Yeah. So what this is actually doing is this is not only building the instance within the public cloud, which takes time, as we know, but it's also now destroying that instance as well to save time. So as you can see, we're down to one's gone.
One gone,
and it's two gone. Yay.
How cool is that?
That's cool, man. Thank you for that education. Every day's a school day, everybody. It's always good to be educated. I like it. Thank you. Right, Church, move over to the presentation. Thanks for that. Right, I hope everybody didn't mind our acting skills. We won't be in any movies soon, I can assure you. But thank you for that demonstration. I hope that shows a bit of insight in the operational handover processes of setting things up from a network and security environment, instead of going through manual ticketing processes and for individuals or for those teams to go through looking to see which is important and prioritize those tickets. Certain things can be done in the background to take pressure away from people. And this is the way we look at it, is to take pressure away from people. And you've just seen that integration and to provide a certain amount of that capability is important. Okay, so what is Consul? What is it you've just seen? From a service networking point of view, Consul provides that security. It provides you with that integration, but more importantly, it's providing you with a real fundamental understanding of all your services and where they exist. So as you saw a web and app service, and they could live not just within one public cloud, but many public clouds and private data centers also. And Consul gives you that real source of truth of where those services are, so it can maintain that security posture and provide that end-to-end service, and also give you that automation piece, which is really important. So from a service discovery and service registry point of view, Consul knows about every service and every service instance. And this is really important because from a Consul point of view, from a network point of view, instead of trying to manage location and IP addresses and then trying to provide a security posture about all those IP addresses, which sometimes not possible because of ephemeral type of devices, we are now managing that fine-grained posture by a service and how many of those instances. And it's providing that near runtime intelligence to allow this ability to manage that manual process between the applications and the networks. And we spent a lot of time from a CI type of point of view, and this is trying to now navigate to that continuous delivery and to stop that delay in that manual process. And also what Consul is doing is providing the ability to try and get away from this complexity. And what we mean by that is most organizations is moving to a multi-cloud strategy, or they're making a migration process from one cloud to another. And that means using different tool sets within those native and cloud providers. Yes, some of them look the same, but we know there's certain differences, which makes it more difficult to manage. It puts a more burden on the operational teams. And to try and get that consistency across, it is very difficult when you're trying to manage a multitude of different processes, services, networking, and even different runtimes. So trying to manage all of this environment and also not take away from the fact that you still have your traditional data centers to consider is moving into this single connectivity across all of those clouds. And from a HashiCorp perspective, we provide this Hashi stack, and it allows you to grow and utilize what you need when you need. So again, we talked about Consul and the utilization of Terraform into the providers, but we also have the capability to make sure that we provide that security using Vault, and also provide an orchestration layer for those multiple runtimes across all those different environments. So this then provides this simplicity of managing one tool set instead of many different native tools across many different clouds, and also utilizing your traditional tool sets that you may have as well. And because Consul is ubiquitous across all of those runtimes, it allows to work with containers, virtual machines, even traditional bare metals. We are not, separating which cloud provider to use. We are just giving you the capabilities to manage all of those applications and all of those services through a single control plane in a secure environment. So from an end-to-end services is totally encrypted. So now, once upon a time, within an environment where networking, all traffic in transit was in clear and open text, from a service point of view, this is completely encrypted and secure now. And this gives us this capability to manage all those different runtimes across all those different cloud providers in a secure, authorized manner. Not only that is, it's complete, it's rich API, so that allows us a complete integration to a lot of different technologies, whether that is from a traditional point of view into the public clouds, or even different variations of Kubernetes, whether that's OpenShift, traditional Kubernetes, or other flavors, within, the likes of GCP. So we allow those integrations and we keep it simple. So you're not adding complexity for that one service to communicate to another. Consul is rich in those telemetry integrations. It's rich in providing you that data to have visibility and awareness. It gives you those capabilities of having multi-tenancy and also to federate from all of those different cloud providers. And from a traffic point of view, we can then start doing, different things, whether we want to load balance it or we want to provide service permissions, so we call them intention zones, from intentions from what service can communicate to another, and provide lots of rich types of services on top of it, health checks, dynamic load balancing, and that becomes very simple and very easy to use from an operation point of view. From a console point of view, from a HashiCorp, we have that stack of information, but we also understand this is a complex transition that we're seeing. This data transformation into this cloud architecture with multi-runtimes in many different ways is very complex. So we're not saying, right, you need to do this all at once. We can start in a crawl, walk, run type of phase, and most of our customers and organizations start with this service registry and discovery. I want to know where my services and applications live, how many are there, and the health of those services without trying to utilize different tool sets. And this is where we start to see the adoption journey of Consul from this point into an automation point, and then maybe multi-cloud federation once you really understand the technology and believe in its power of integration. From our poor acting skills that you saw, we show from a sole manual process, we're not relying on a Jason and Jonah conversation. And that's just one conversation. How many more of those are happening in the background? How much time is lost due to trying to make sure we maintain that fine-grained security posture while also adding, different VMs into that posture as well. And by having this manual process, we're increasing the possibility of mistakes. By having an automation point of view, we're reducing the risk, reducing mistakes, and also making sure we provide a cost-effective way of making sure we hand that transition over. And then this is, very impactful. We've just shown something of how to add, remove, create an end-to-end service within, a very quick, time, couple of minutes. By the time it's spun up some VMs and some services within one of the public cloud providers. But to hear our customers say, that can take a long time, days, weeks, just to try and get that application to your customers to make you competitive in today's market. And that's the reason why we see so much benefit within network infrastructure automation. And this is the process, this is generally the processes that we see, the operational handovers across many different operational teams. Even we see some consolidation across those teams. It still takes a lot of time to get from what a developer wants to make sure that a security team maintain that security posture until that application is then delivered to your customer. And that's the frustration of it all, and that's why, you saw a lot of shadow IT many years ago because of that frustration. And hopefully what we're trying to prove is we can get rid of that frustration and show a real seamless way of getting this achieved in a lot quicker.
Cool.
So, thank you. Over to you, Yona.
Yeah, so let's dig a bit deeper into the network infrastructure automation piece and what's actually happening in the back end, right? So why is this important? Let me see if I can click. So the objectives of DevOps is to bring development and operations closer, but we are very far from it in a classic way of doing things. If you take a look at the deployment process, I develop, I match my source control, I test, I want to test, I want to release. But the test and release is not as straightforward as many may think, because part of my testing involves deploying my application, connecting them to others, asking my networking teams to do things like we role-played earlier on, Jace. And then if I need to fix something, I need to go back, redeploy, refix, and maybe it's because these VMs are very ephemeral, so I may get another IP, I need to go back through that process. So that can be super painful, right? And so basically that continuous delivery and manual deployment, it's that manual deployment that we need to get rid of. So basically, if you take a look at, very often this means you, Jace, you showed me earlier, you went to the interface, you clicked some buttons, you may have some scripts, right? We made that, we're doing with some scripts here, but it still requires me to open a ticket, somebody approves it, and then finally I can then consume that service, or anybody can consume that service. So it continuously delays my delivery process of my new features, new applications. So then there is the handoff, right, to the networking teams. So this is also where, so that manual handoff to the networking team, so they may still running their scripts, but I still need to provide them with that information. So you may have all the automations in place that may exist, but I still require to put my information again into a ticket. You consume information. You may have all the scripts in the world, but it still requires a lot of manual work in the middle, right? Assuming you don't do service mesh, assuming you actually have to change your network appliances and update the network appliance in the middle, this adds an extra level of complexity here. Again, a lot of delays and constantly facing with these delays just to test new features. And in today's landscape, these delays are not acceptable anymore. I need to be able to become more agile and be able to test things on the fly without bothering any other team. This is where Consul comes along and Consul Terraform Sync. So basically, what I'm going to do here is I'm going to now automate. I'm now going to automate the network infrastructure in between. So Consul, again, just to go one back, sits in the middle. So I deploy my application, Consul then reads that information, pushes this out to the network and updates these appliances on the fly. So Consul is aware of everything that happens. My Terraform Sync is then automatically aware of what's happening and will update that infrastructure in the backend. This is where network infrastructure automation comes along. Very often when companies start to adopt a control plane like Consul, which includes service mesh, a natural step is going from service discovery, which is I'm a big phone book of services that exist, all while automating my infrastructure. then the next step is then adopt service mesh for mutual TLS and secure communication. But very natural process is to go via that network automation. So what do we really need? Consul is that source of information where all healthy services sit. So Consul knows at any moment where the information sits. And then also a tool which allows to automate changes in network infrastructure. So one thing is good to when I get started, but also because I dynamically need to change my infrastructure. So what I showed earlier was the I have an event, so I may have automatic scaling. And these changes very often lead to have a loose grain policies on my firewalls and load balancers by saying I'm going to allow a complete subnet, right? Or I'm going to allow a certain VLAN, whatever the thing is you do. By adopting Consul, you can go to fine grain policies and automate the whole thing, right? And then again, Consul just ties everything nicely together. Again, so how does Consul Terraform Sync works? In the backend, Consul speaks to Terraform Sync, talks to Consul. Terraform Sync will fill in a variable file inside on the Terraform Sync, let's say client. That file will then be used by Terraform to update and to talk to use the modules that I showed you earlier in the demo to talk to your firewalls, load balancers, and any other appliances or any other Terraform modules that you want to integrate that to automate that infrastructure deployment or automation behind Consul. And the nice thing is we have a really robust ecosystem of modules that you can use and automation you can put behind this. Cool. So again, Consul really fills that gap. So on one side, you have Consul that knows where all healthy instances are of a running service. And then on the right side, you got the Terraform that can take a list of healthy services. As I said, we fill in a file with some variables, with the instance information that comes out of Consul. And it will drive this network device configuration on the fly while changes are happening in Consul. And this, as you can see, happens quite quickly without any human intervention. So basically, just to recap, to change that again, there is a change in service instance. CTS watches for that changes all the time, so it's a service that runs in the backend. CTS will notice that change automatically. You don't need to do anything, and they will trigger that Terraform scripts in these modules. And very important here, you can include an approval process. It can go to a workflow. So if you want, for example, things to be less dynamic, but still have some involvement, but automate the configuration, but you still want to integrate with your existing ticketing system, because it is a big step to go from no automation to automation. So if you just want to see things happen before they happen, you can still use the whole the Terraform Sync, for example, with or Terraform Enterprise, to make sure that you integrate with your different teams and you include that approval process that Terraform Enterprise is so good at, right? So it's a really important point here to mention that adopting network automation is not that straightforward for a lot of companies, right? Because it still requires the network team to trust what's happening, and including an approval process in the middle is a very good intermediate step. Again, here, basically what we do in network infrastructure automation, we combining the strength of Consul and Terraform, right? Across all clouds, so I can automate clouds networking. I can automate different platforms. In this case, like for example, Fortinet, Checkpoint, Palo Alto, AVI networks, VMware, F5, Cisco, just name it, right? We got a lot of providers. Even Citrix, for example, is also one we can automate for the NetScaler. So Terraform has over 150 providers that you can include it in that automation process with the information coming from Consul, which I think is super cool. It just makes sure that no vendor locking, you continue to use the vendors that you always work with, but you just automate that process with information coming out of Consul, right? Which is, I think it's just very exciting. So yeah, so I think we went through the biggest point within of Consul network infrastructure automation. I think it's pretty clear that by adopting HashiCorp Consul Terraform Sync really automates that classical way of doing things by using infrastructure as code, all while not losing control of what's happening in the back end, while you on that journey to adopt Consul and that control plane that includes service discovery, service meshing, combining all these clouds and different runtimes, basically making you move to cloud and the application transformation process way smoother than it is today, probably, right? So what I would really advise everybody, if you want to know more, we have a set of workshops they run through when we go. It's a one-on-one workshop with you and your company, when we really go into the details of what Consul is, what Terraform Sync is, and we can go in details of your particular use case as well on these type of workshops. So if you think that's valuable for you, just let us know, and we'll be happily organizing a next step with you guys. Cool. I think there is plenty of questions that will drive us to some nice discussions here. Jace, have you so let's go through this question, have some interesting discussions here.
Okay, you got control. One thing I'd like to add on the Terraform vendor list, which was quite interesting. We have a huge community behind us. You know, HashiCorp, you know, is works in the open source worlds with the public communities, and a lot of these providers are building a lot of integration connectivity into Terraform. So that list has grown exponentially over the years and will continue to grow. And Consul Terraform Sync is very popular in that growth as well. So yeah, it's going in one direction, which is really interesting and very, very appealing.
So let's go to a few of these questions. There is one in the Q&A here by the one and only my twin brother, which is on this call. So he just wants to make my life difficult. No, just kidding. No, the question is, why do you need additional service for syncing service with F5? Can't you just use Lambda function in AWS or such for direct communication with F5? That is true if you just use AWS, right? But very often it's not limited to AWS. It's limited to other clouds. You may facing with on-premise clouds, multiple clouds. So yeah, your statement is true, but that will limit you to stay within AWS, right? But if you would need to automate that communication in between clouds, that is just something that not going to cut it with just Lambda function. This is why. So as Jason showed the Hashi stack earlier, really what we do, every single cloud has their own control points, their own way of doing things. The end result is very similar. But what Consul, and just generally speaking, the HashiCorp stack will give you is that overall single pane of glass connection with every single cloud. So all you need to do is provide different modules to these clouds and different runtimes, and the front end code is going to be very similar by thanks to Terraform, Vault, Consul, and everything else that connect these clouds together.
Yeah, can I say one thing to that, Yona?
Yeah, sure, absolutely.
It's a great question, and as we move into this multi-cloud world, we always seem to forget or negate the private data center traditional world that is there, and you know, from our perspective, we're not trying to just fix a particular element in a particular cloud or a particular runtime. We're making sure that we utilize the whole picture. And that includes your own private data centers and your traditional infrastructure that is there. So, and that's a bunch of infrastructure. So to not think about that as part of the strategy, I think, you know, is missing. And that's what we add. We add that missing piece within that jigsaw.
I hope we answered your question right. So I think there is another question, Jason. Is the Consul the same as the controller of SDN, right? So I'll get started with this, and you can chime in, Jace, if you want.
Sure.
The thing with SDN, it still requires you to know about the services and instances and IP addresses, all that fine-grained information that you need to provide in order to. So SDN works, right? But you still need to have a source of truth to provide that information to you SDN, right? And this is where Consul comes along. Consul can talk to your SDN, right? But Consul will just make sure to provide that information that your SDN needs in order to be able to get updated and automate that software-defined networking.
Yeah, and as we showed in one of the slides, as one of the vendors, you know, if we're alluding to likes of ACI, then you know we have modules that can start automating, you know, into ACI as well. You know, so again, they're great discussions to have. But as Jonas says, you still need to have that fundamental understanding of where your services are and how they live. And that source of truth that Consul provides, that's the important part.
Cool. I hope we answered your question. It was, I hope you answered your question. It was from Pons Cruz. So there was another question here. As far as I understood, you said there is an integration with the public cloud provider. What kind of integration is that? What does it consist on? Jay, do you want to answer that?
So from our perspective, we provide integration into all clouds, whether that's private or public. From a Consul perspective, you know, we make sure that we manage our local clusters within those environments. And then what we can then do is provide a integration, we call it federation of those devices across mesh gateways. So we can provide that integration. We can utilize and work with all the different resources within those providers to deliver a complete visibility of where they are and how they live. You only gone quiet. I think mute button's been hit.
Yeah, sorry, I went on mute by mistake. Did we answer your question, David? Yes, awesome. So we have another question. Are customers usually happy enough with Consul embedded health checks? Or are they looking to integrate with their existing monitoring infrastructure? Very, very good question. I would say both, right? So Consul, they're usually very happy with the health check, but that information is being fed into their monitoring system, right? So basically, what's happening? Instead of, so with the health check systems, you still need to integrate with your infrastructure, which still requires to do some work. Again, that manual work of integrating and including these endpoints and so on, right? So basically, the short answer to your question, both of the best of both worlds. So basically, Consul will do the active health checks, and with the service mesh, for example, with the Envoy SAT cards, and just generally speaking, the metrics and tracing that Consul can expose can then be fed into this monitoring system, and any health checks or any control point that Consul doesn't provide, you can just superpose to whatever you already monitoring today. For example, one thing is monitoring your networking communication, but there's other things that they wanna be able to monitor, like memory consumption, etc. So basically, by marrying these two things into your monitoring system, you can now go and put, hey, I got a networking issue, I got an issue of that service, or that went together with some memory, with a memory peak. So you can start marrying these two things very easily, and get to the bottom of your issues very, very quickly. So short answer to your question, they very much trust Consul, but they integrate that into their existing monitoring system.
That's right, yeah. Observability is key, you know, so we can feed those metrics into a lot of tool sets to give you that trend analysis, to give you that, to get to that root cause analysis of what's going on in your environment. So absolutely, we have that, you know, rich API that has those open integrations, and you know, we can show those things into like Jaeger and Prometheus and displaying Grafana. So, you know, that's an as examples, but plenty more, absolutely plenty more.
Yeah, absolutely. Then there is a question here. If someone wants to keep an approval step before adopting full network automation, how do they do that? With Sentinel? So yeah, well, I'll get you started with that, and I'll continue. We'll just take a question one by one.
Yeah, sure. So from a Sentinel point of view, we can add those guardrails to make sure that your developers, your team members are actually provisioned the correct infrastructure at the correct times and making sure that you meet your requirements. So we put those guardrails in place. So again, as the deployment is taken in practice, we can make sure that with Sentinel, we can put those rules in place to make sure that we manage your correct corporate policies and processes. So really important. And again, to make sure whether that's sizing, whether that's costing or location, all that can be managed through Sentinel.
And just to add, there is an extra thing, not just Sentinel. So with the integration with Terraform Cloud and Terraform Enterprise, now, when a Terraform gets applied, you can have an automatic approve, but you could also make sure that somebody manually needs to go to Terraform Cloud and approve that deployment, right? So Sentinel is one thing because it will make sure that only certain people can approve certain modules or certain changes. But by integrating Sentinel both and using the Terraform Cloud and Terraform Enterprise integration, it just adds that extra step where actually someone needs to log in, it gets a notification, hey, you need to approve something. Right. It can review the plan, the Terraform plan, because Terraform plan will just specify exactly the changes that need to happen. And once that is done, you can then approve it or not, right? And provide that feedback, you can add comments. If a change needs to happen, send that back if necessary, and get that approved. But the ideal thing is to have things automatically, to have no approval, of course, because that's where you get the real dynamic things. But we very often see customer going through that step in adoption of automation because it's difficult to trust something that is foreign to your company that does things automatically, right? Right.
And if you saw what Yona was doing when he was adding that Terraform piece, he had auto approve at the end. So he was the approver of his own piece of work, which generally not a good thing. But you know, again, it shows that the approval process is there. It's just for our process to make it a lot quicker for today's demonstration.
Thank you, Jace. Thank you. Cool. So there is, I think, thank you, Dorina. So I hope that answered your question. Dorina, apparently, yes, it did. So I think there was a question from Mario, app pool instead. I'm not sure what that question was related to, but I hope we answered that in the meantime. Sorted. Okay, thank you. So that we answered that question in the meantime. So I think we show really the strength. If you want to go back to that console UI and very quickly, we just to sum up what we just did, just do a summary and next steps, just Jace, because if you just want to go back to that console UI or that Instruct Lab, just to sum up what we just did. So I lost control of your screen. So if you go back. No, that's fine. That's fine. That's absolutely fine.
Yeah.
So basically what we did here is we didn't go into detail what console is, but as you can see, console is that that central registry of services, that central control plane that connects all these services. You can see at the top it says DC1, but we can connect many DCs in many different runtimes in many different clouds, and all manage them centrally. And having something in the middle that automates the whole networking in between these environments is just super valuable. So really what we did here, we took that information out of console, the agent read that information, because while I register services, which is it's a very simple binary that gets started on a VM or container or whatnot. So this registration happens really fast and really dynamically, but by adding Terraform Sync, at the same time, I'm allowing to also add that dynamic way of working to my network infrastructure. Right. And if you, do you want to add anything?
Yeah, all I'd like to say is, you know, what Yona alluded to here, the power of console is providing you access to all of those cloud providers. So yes, we only have one today, but there'll be a drop-down menu here, and that could be Azure, AWS, GCP, all your clusters. So you can have one place to have a look at all those services, you know, and we can then, you know, really then interrogate, you know, it provides the IP address and port numbering along it, alongside it. So we can give you all that information, not of only just the services, but also the physicality that hides behind it as well. So those IP addresses that are difficult to find, whether you may be using, your DDIs or your CMDBs, or what I like to say, spreadsheets, this now giving you this real-time understanding of your complete allocation of those services and nodes that are allocated with it.
And just to quickly sum up, as we said, we talked, so will Consul do the initial discovery? Very good question. No, right? Well, let me rephrase that question. For discovery to work, right, the service needs to register himself. So if you're gonna add, if all we need to do is add an agent and make sure that that agent knows about the service that's running on this instance. And Consul can be managed using Terraform as well. So if you got your environment run as with Terraform with infrastructure as code or any other infrastructure as code, doesn't need to be Terraform, you can include that agent configuration into your workflow and make sure that this configuration gets updated. So if you got your dynamic, your groups in AWS, you can change your instance information to include that Consul agent, and on next boot, it will just, next time that the extra instance gets added, you can make sure that these instances get automatically registered. So the initial discovery, the short answer is no, but it can be made really dynamic.
Right.
Does that answer your question, Dan? So can you explain an example how you would do the F5 big IP? No, sure. So Dan, very good question again. So basically, so one thing is registering these services. So the automation to your network appliances is making sure that while your environment is super dynamic, so once you move to that service discovery mechanism, once you discover these services, once you updated your instances to automatically register themselves, right? While they register themselves and deregistering themselves, this is where you need to go and constantly update your F5, big IP, and so on, and these type of things. So to adopt that service discovery, the update requires you to do some pre-work to make sure your service get registered, that everything gets integrated to Consul, which is quite an easy step. The service discovery is straightforward, to be honest. And once that service is discovered inside Consul, then Terraform Sync can do the rest. Does that answer your question, Dan? Cool.
Very good.
Awesome. And then I wanted just one last thing. So that there is a few other use cases in Consul that we can have separate meetings. So we got a key value, and you can see there is ACLs or intentions. I would invite you to have a look into that. Key value for example, automatic application configuration ACLs to make sure that services get authenticated, and intentions make sure that services, you approve the communication in between services, right? So all these things are things that would, if you're interested, let us know, and we can run a bit more deeper sessions into the functioning of Consul.
Absolutely. And just to add on top of that, why we have a couple of minutes left, is we can provide that multi-tenancy environment as well. So maybe as a service provider, you will have multiple customers. We can break this down into partitions to allow that multiple access. So Jason can only see his particular elements. Yona can only see his particular infrastructure and services as well. And then we can then manage our intentions and security postures across that as well. So we can really be very granular in how we manage and separate our capabilities for our business to make sure we maintain all our customer security and privacy. And at the same time, we can scale to huge amounts of services to support your business as well.
So I got another question from David. I'm not sure we have time to go into details of that question. David, imagine we need high connection performance, SSL offload, or any other reasons we want to register a load balancer in, let's say GCP into. Is that possible? Short answer, yes. But we'll need to, yes, absolutely, because that's a quite common use case. But I would say, David, if you go back to the presentation, our email address is there, right? I would say if you want, let's have a separate connection, a meeting if you want, and we can go into details of this, because this requires a bit more explanation on the use case.
Right. Connor, do we have any more questions?
No, I think that's it, folks. So Jason, Yona, thank you so much for that presentation and demo. And as you say, it doesn't look like we've had any other questions come through. So with that, we'll conclude today's session. And if you did want to learn more about Consul, then firstly, I encourage you to check out our Learn site, and you can find that at learn.hashicorp.com/console. Or as both of the presenters mentioned now, you can also arrange a half-day workshop with us. Well, you can get hands-on with the technology and learn what Consul can do for you. So you'll find more information about that in the follow-up email I'll send out, along with the recording tomorrow. So with that, I really hope you enjoyed today's session, and we look forward to seeing you next time. Thanks, everyone. Goodbye.
Thank you. Bye, everyone.
Thank you, everyone. Have a great day.
Thanks all.